Hello guys, welcome back to my channel. So today I'll be discussing about all divisors of a number in mathematics subtopic. Okay. So today let's start with this all divisors of a number. So 1 minute. Okay. So all divisors of a number means it prints all the divisors of a number. So for example, if I give a 36 number, then it checks the all the numbers like which is divisible by 36, then it prints the all the values until 36. Like how many numbers will be divided. And definition is nothing but a divisors of a number n are all numbers that evenly divide n. So since n remainder I equal to 0. So now let us take out a real life example. So divisors are used in LCM or HCF factors, mathematics problems and number theory. Especially in mathematics, we are going to use a concept divisors, right? So they are very important in optimization, puzzles and also event systems designed for load balancing. And coming to approaches, there are two types of approaches. First one is naive approach and second one is optimized approach. So naive approach is it checks every number from 1 to n, and coming to optimized, it checked up to square root of n and use space. Okay. And the time complexity here in naive approach there is time complexity is big O of n and space is constant, and optimized is space big O of square root n and space complexity is 1. I'll be explaining code at the end of the video, and how to answer if this question is asked in interviews. So if you want an output in sorted order, store devices in two lists, one for I and another for n by I, then reverse and print. This is for sorted output and it is not necessary. And coming to how to answer this question if it is asked in interview means, we need to answer like to print all devices, I iterate from 1 to square root n, and for each divisor I also print n by I to get the pair. This reduces the time complexity from big O of n to big O of square root n and avoids unnecessary checks. So this is how to answer in the interview. And now let's see the code and also try run with steps. Now let us see the code and also try run of all divisions of a number. So I actually declared the number n equal to 36 and I passed it through the parameter of div num. Okay. Now let me write the for loop. For I int I equal to 1, I less than math dot square root of n. Okay. Math dot square root of n and I plus plus. Okay. And I plus plus. So here if n by I is equal to 0, then it need to be printed. I'm writing shortcut SOP. It is nothing but system out dot println. So SOP plus space. Okay, this is what it have to print. Okay, and now if I is not equal to n by I, then it should print SOP of n by I plus bracket close. Okay, this is how this program looks. Okay, so whenever it is equal to 0, then it prints I value. Whenever it is not equal to 0, then it prints directly this value. Okay, now let us see the dry run. Let us see the dry run. So actually I gave n equal to 36, right? So first step is n by I, we will check now. So 36, at iteration I equal to 0, n by I, wait a minute, I'll make it a table column. So I equal to 0, n by I equal to 0, and I not equal to n by I. Okay, printing statements, it will be printed here. Okay, so I equal to 0, right? So I equal to 0 is nothing but whenever I equal to 0, then 36 divided by 0 is equals to 1 actually. Then we get answer as 1 only, right? In table it divides, so we will get 136 are 36, so we will get remainder as 0, so it prints 1. And now again we need to check this thing here also. So 36 by 1 is equal to 0, or is equal to 0, right? But it is not I. It is not equal to I. That is 1, which is not equal to 1. So again we need to print this value. So how much we will get actually here? So we get 36. Okay, now I equal to 2. 36 by 2 is equals to 2 ones are 2, 2 ones are 2, then we'll get 18, then we'll get 18, right? So here it will be printed 1 comma 36 comma 18. Okay, and now after that we need to enter into this loop, right? So here we'll get 0, and again 36 by 2 means 18, which is not equal to 2. Here I value it is not equal to 2, so again we need to print here we need to print 2, and here we need to print 18. Okay, because here I actually mentioned that I equal to 2 we need to be printed, and here I have to mention n by I value, so I mentioned 18, so it is the divisor of 18 also. Okay, now I equal to 3. 36 by 3 ones are 3 12, it is also equal to 0. Then I comma 36 comma 2 comma 18 comma, so what was the value? I is 3, right? So I printed 3 here, and now I need to enter into this loop. So again we need to check here. So 36 by 3 means we get 12, but it is not equal to I value, right? So we need to print 12, and now I equal to 4. 36 by 4 is nothing but 9. This is equal to 0. So print 1 comma 36 comma 2 comma 18 comma 3 comma 12 comma. So here we need to print I equal to 4, and then next we will enter into this loop. So here 36 by 4 ones are 9, which is not equal to 4. So we will printed 9, and now I equal to 5. So here it completely doesn't belong. I mean in 36 by 5 it is divided by 5 is not equal to 0, so we'll skip this. Now I equal to 6. We are at the end of this loop. So this is the last statement, because I actually mentioned the condition I less than m square root of n. So here we will get 6, right? So 6 is the last condition. Now we will be using 6, and we'll be stopping the try run. By 6 is nothing but equal to 0. So here we will be getting 136 comma 2 comma 18 comma 3 comma 12 comma 4 comma 9 comma 36% 6 is nothing but we get I equal to 6, and again we need to check this condition, right? So 36 by 6, 6 ones are 6 is 36, right? So 6 ones are 6 is 36, and it is same. However, it is not 6 equal to 6, right? So this condition is false now. I mean this condition becomes true. So we'll skip this and directly print these are the values which are divisors of the 36 number. Okay, this is how we need to initialize. This is the dry run of this entire code. And coming to time complexity, we are entering into 2 for loops, and also this I++ is nothing but n. Whenever we use n, I mean whenever we use increment order, then we need to write n, right? So time complexity becomes square root of n, and space complexity becomes big of n. It doesn't take any extra space, right? It doesn't return anything. So that's what we got this thing, and this is how the entire code looks. And now let me write the steps. So steps are nothing but just we need to remember the condition. If n by I equal to 0, then we need to print the I value. If n by I is not equal to I value, then we need to print n by I. Just remember, n by I equal to 0, then print I value. If n by I is not equal to I, then print n by I value. Okay, this is how it works, and that's it for the video. Let's see in the another video.